Let's try exercise 17.19d from Munker's textbook. If U is open, is it true that U equals the interior of the closure of U? Justify your answer. So we're taking an open set and presumably making it bigger by taking its closure, and then smaller again by taking its interior, and we end up with an open set, and we wonder whether that's the same open set we started with. Okay, well, in some cases this would work out, right? Think about, for example, the open set, just the open interval from 0 to 1 in the real numbers, okay, with the standard topology. For this example, if we try to compute the interior of the closure of this U, well, let's see, the closure is just going to be the closed interval from 0 to 1. Right, we just add in those two endpoints. And then the interior of that, we're going to throw the endpoints away again. So we just get the open interval from 0 to 1, which is the U that we started with. Okay, so it's kind of an intuitive statement. You might wonder whether it's true in general. Turns out it's not. So this, let's say, this equality does not hold in general. Okay, let's give an example where it does not hold. So one easy one would be the particular point topology on a set X, okay, for some point P and X. And let's assume that this set X has more than one element, and the reason is I want there to be a proper subset A of X containing this point P. Okay, if the set X consisted just of P, then any subset containing P would be just that singleton P itself, and it would not be a proper subset of X. Okay, so let's just assume that there's at least one other thing in there. And so, let's see, we showed in exercise 2.4 earlier that for any such subset A of X containing P, the closure of A was equal to the entire set X, right? Because X was the only closed set in this topology containing A. Okay. And well, X, that's the entire set that we're working in, right? It's both closed and open, okay, as with any topology. And okay, so because it's open, if we try to take the interior of the closure of A, that's the interior of X by what we just did, and because X is open, that's X, right? And that is not equal to A, right, since we guaranteed that A is a proper subset, which is just a fancy way of saying that it's not equal to X. All right. So we've shown that this equality does not hold in general.